Hi, so this should be an interesting video. What we're going to cover is functions and operations executed in the editor build versus package build. And for this project, I also have it put up on GitHub. So if you want to check it out, modify it, just play around with it, you can find it here. So let's go into the project. This is how the different builds look. So we have our editor, development, and package build. And the reason why I didn't just go with editor and package build is because in the middle of testing, I noticed that in development build, I was getting some different numbers. So we have 3 builds. We can see this editor build is actually running in the Unreal editor. I'm just having a separate window for this instance, so we can more easily see it. We don't have to play it directly in here. So now that we have that covered, let's cover this UI and let me familiarize you with what we're going to be looking at. So first we have our current test, so it's just going to be the name of the test we're running. Then we have different tests. So we have for loops, for each loops, while loops, reverse loops, recursion, spawn actor, and save and load. And there is different modes for a few of them. Of course, I could expand and add more and more detail, but this is kind of where I stopped and decided to make a video about it because there is few interesting things I noticed here. Then we have how many loops we want to make. And for a lot of things that if you trigger them once, it's going to be not that costly. I wanted to showcase if you try to run it at mass. For example, spawn actor, we are going to spawn it 6,000 times all at once. Save and load, trying to save it thousands of times or load it thousands of times. And also we have stuff like, do you want a light blueprint, meaning almost empty blueprint, or do you want something a bit more heavy? And we have basically these 3 builds that we're going to be covering. Okay, so first let's start with a for loop. So what we're going to do is click on this button and we're going to run an empty for loop 100,000 times, and it's going to be in editor. And in here what it shows is how long it took in the development and packaged, and you can see here percents, and it basically says it took 10 times longer in editor than in development build and 15 times longer in editor than development build. So there were some optimizations done on this functionality in development build and some additional optimizations in package build, or something different basically happened. So when you're looking at your game and how your game is going to run in its final form, it's going to be this package build. So we can see that it actually needed pretty low amount, so 0.007 seconds to run 100,000 for loops, which is actually pretty nice. I think for C++ it would be like a half of this time or something like that. And the reason for that, I think, is that it is nativized, meaning it is converted to C++ code to squeeze out as much performance as possible. And if we look in here, you can see how much longer it took. So 0.1, just to give you a perspective, this will be 1/10 of a second. If you have a game that is 60 FPS, basically your game is going to freeze for 6 frames to do this operation. So let's test out the next thing. So this is for loop where we just set an int. So every for loop, we're just going to set one int. So I'm going to do set loop. And when we do this, you can see how the development and package now say that there is no option in here. That is because I have, let me actually show you in the folder. If you go back here, we have this JSON file where I save all my performance tests. And because I haven't done this specific test for loop 100,000 times on my development and package build, that's why it's saying basically there is no information about it. So let's do that. I'm gonna change this to set int for loop, and then in here set int for loop, and we can basically see what happens. So in here we get similar thing. We can maybe do it a few more times just to see if something changes. Usually when you do it a few more times, sometimes it does it a little bit faster because there's some caching or something happening. So we can see that we're still getting similar times. So let me actually increase this, let's say 500 times, and click for loop. And now we can see that the package says 0x. That's because we don't have editor, and we compare the number, how much faster it's going to be from the editor. So since we don't have anything in the editor, we have to actually do it in there. So let's actually do it here. So I'm going to do 500,000. Let's do for loop. And if you noticed, it froze a little bit, that because we had to wait 0.6 seconds for it to actually do anything. And let's also do it in here. So I'm going to do 500,000 for loop, and we can see this. So small thing that we notice in here is that we are losing a little bit of that boost. So now it's 12, 13x. It's not that big of a deal. Before it was 15 times faster. So we lost a little bit, but still pretty fine. One thing I haven't mentioned is this seconds in here. So I also made it increment to milliseconds and also microseconds. So for example, if you try to do just one for loop in here, you can see how it took 0.0004 seconds. And if I do same thing in here, so we get that perspective, you can see how we actually do not get much of a boost. So we actually get that performance boost when there is bunch of loops, not when there is just few of them. And in here it says US, meaning microseconds basically. And if I do, let's say 100, we should go into milliseconds. So you can see 1 millisecond. So if let's say we do 100 loops, so I'm going to do 100 in here, let's do 100 here. So I'm going to do a few times just so it comes down there, another 100 here. And we can see, because it is a lower amount of loops, the performance boost is not that crazy. If you want to get maximum optimization, you're going to have to do a bit more. So maybe let's say 10,000 loops. So let's try that number, 10,000, and then 10,000 in here. And you can see now we're approaching that 15x boost we had before. So pretty interesting. This kind of tells you that if you're in the game and you maybe get some hitches with for loops, that doesn't necessarily mean that's going to be the player's experience. Maybe it gets heavily optimized, but also maybe not. So you have to test in the package version. Okay, so let's continue. Now let's do for loop with break and see what happens. So 100,000 in here, 100,000 in here, and then 100,000 in here. So now with break basically means that you have that one execution pin that you can basically stop your loop. And because you have more stuff that you need to do when you're stopping your loop, it's going to be more expensive just as a baseline, but also a little bit less optimization. So if you do normal for loop and we do 100,000, we can see how it's around 0.12, 0.012. But if we do this, we can see how we are increasing it with maybe 50, 60, 70%. So that basically means that for loop with break gives additional performance overhead, so you need to worry about it. And not just in the terms of a little overhead, but also in terms of optimization, where package build now has trouble to go to like 15x improvement. Okay, so next is for each loop. For this one, I think I have integer array that I just fill up, and then we go through that array with using for each loop. So let's press on that, and let's press it everywhere to see what we get. Now, because we are again doing the simplest form of loop, but this is for each loop, we can see how we are getting a bit more of that optimization back. It's not 9 or 10x, we're getting like 12x. And we are closer to the normal for loop. So normal for loop gives us 0.12 in the editor, and similarly here. But our for each loop with break actually gave us more than our for each loop, even though generally this is more expensive than this. It just tells you how much this break actually increases the cost. Then let's do for each loop with break. And for each loop with break, we get the similar thing where we have the 9x improvement, a little bit in development and also in editor. Nothing much to say here. Same thing, we get a little bit more overhead. So let's go to while loop. While loop is actually not that bad. We can see how in the editor we have our 0.12, so similar cost to the normal for loop, but we also get huge optimization improvements on package builds, which is kind of nice for while loops. Now, for while loops, you have to be careful because you will have to manually set conditions to when you want to leave the while loop. That's the thing that you're going to have to manage. So there is going to be additional codes. And keep in mind, this is all loops that are empty except these in here. So while loops will have to have additional functionality to check when you need to stop looping. Because these loops are all empty, that means that this is the best case scenario. You're not actually going to see these numbers practically in your game because you're going to have code after the loop actually executes. So in the loop body, you're going to have a bunch of stuff that needs to happen each loop. So this is kind of the best case scenario. And also I'm not using thread safety here, so this is all just single threaded. Okay, so next is reverse for each loop. So let's do that one. Okay, again, pretty nice numbers in here. We get good optimizations and also similar to normal for loop. So not too bad. Next thing, before we go to recursion, let's cover one more thing. That is nested for loops. So this is for loops inside of for loops. Now for this, I don't think I can go even 10,000. So let me try to go that. We can see we can only do between 0 and 900. And that is because we are multiplying 900 by 900. And that is, I think, what is that? That is like 500, 600,000 or more loops. So we need to do, let's do 900. Let's do maximum amount. So I'm going to do it in here. We need it in here also and in here. So let's first do it here. And we saw just a huge freeze. It almost needed a full second to loop 900 times and then each time again 900 times. Let's do in here first. So as you can see there, way faster than this loop. And let's do here. So this is interesting. I didn't think that nested for loops will get also this type of boost. I thought it would be a little bit lower, but it seems that they also get a huge boost. So we went from waiting a full second for this to execute to waiting probably like 2 or 3 frames maybe. If you're playing a 60 FPS game, so still huge, but way lower than whatever we had in here. So in editor, this would be a full freeze, while in the package build, it's going to be a little hiccup, basically. Okay, now let's go to recursion. So I'm going to do recursion in here, then here. Okay, so for recursion, you pretty quickly hit the stack overflow, so I had to limit it to 2000, so we cannot go above that. Also, in Unreal, you can also set the recursion limit. In here, I set it to, I think, around 2 to 5000, so we're safe to do, but I think before, the default value for recursion was at around 500, but you can see still in here, we needed 0.001 seconds. I think we can actually test. The recursion function was empty, so we're going to do the same thing in here. So you can see the cost was similar. Maybe we can press a few more times. So 0.001 0.002, and then for recursion, we're getting kind of similar numbers. Sometimes you get worse, sometimes better for recursion. I think it's about the same as for loop, maybe a little bit more expensive. Right now it's showing actually better numbers, which is nice, but I think in general you're gonna get a little bit worse numbers. And also you're pretty limited with the amount of recursion loops that you can do. Also optimizations do not go hard here. So you can see that we get 0.0002, and let's try for loop for the same amount. Let's try it in here. So I'm gonna do empty. We can see 0.00014. Let's do recursion. For recursion we get about almost double, like 1.8x more expensive in the package build. Even though it is a little bit cheaper in the editor, it is a little bit more expensive when you actually package it. So do not get the same performance boost when you're packaging them. Next thing, we have the spawn actor. So let's do that one. Okay, so we need almost 1 second. Let me spawn again. Okay, so we're getting about 1 second. Let's do it here. And you can also see this box spawning. That's because we actually have one actor and then one component that is a cube inside to give it more realistic situation that could happen instead of just spawning an empty actor. Okay, so spawning 6,000 actors in 0.1 seconds in package build is actually pretty nice, especially since we are spawning 6,000 unique actors. This is not instanced meshes or anything like that. This is actual new actors, and they also have one component. But because we are creating a light actor, so actually I can show that in here. Let me open up the actors. So the light actor is basically just one cube and nothing else. Very light. Let me move this. Now what I'm gonna do is go to moderate amount of stuff inside. So let me open up my blueprints. I actually need the other actor, moderate. So for this one, I try to add few variables, few functions, random events, random stuff, just to have something in the event graph. And then I added 5 components, and let's try to play that. For that one, I think we have to do to 2000 because we're gonna go to way above 1 second, and measurement I have is just for around 1 second. So let's go to 2000. Let's do spawn actor. So 9.1. Okay, we got a little bit lower numbers. Then let's do 2000 here. Moderate, spawn. So there's a little bit of optimization that seems to happen. Maybe some caching. So let's do moderate. Let's do 2000. Good thing is that we still get some optimization, but we can see that optimization fell a lot. And also we are spawning 2000 but getting similar numbers to when we're spawning 6,000. And for me, the surprising thing in here is how little stuff I actually added. I did some additional tests that are not included here, where I try to delete component and see the difference if I only have, let's say, events and some functions versus if I delete the functions and variables and I just have these components. And the components seem to cause probably around 90 to 95% of the performance difference. These things did not make much change almost at all. Of course, if you had a event begin play and you have additional stuff that needs to run every time the actor is created, then of course that's going to be more expensive. But components just by themselves seem to increase the cost by a decent amount. So that's a surprising thing, where I learned that components actually, just by having them here, have a huge performance hit. One thing that I tried is just added a scene component, and if you ever worked with a scene component, it's basically almost like a 3D location in space. It's a component that you can't do much with. You just have a location. It's one of the simplest types of components. And when I added 4 of them in here, my performance increased by about maybe like 10 to 15%. Adding just the simplest type of component can already boost the cost for spawning the actor. The takeaway here is that if you have an actor that needs to be spawned frequently, try to minimize the amount of components that it has. And of course, if you have stuff on event begin place, you could also try to figure that out. But interesting stuff, how performance rises. So for example, let's do our light version and let's do 2000 just to show you the difference. So we went to 0.33. We almost triple our cost, and all I did is just add 4 more components. And also we lose our optimization for package. We are at 4.3 instead of 10 or 9 or whatever we had before. Okay, the last thing I think was the most interesting that I saw, which is save and load. Let's do that one. Okay, so I pressed save on all of them multiple times just to get some consistent results. And the biggest surprise for me here is that in the package build, it actually is consistently more expensive, usually 30% more expensive. And I expected it to not be optimized almost at all, because you're dealing with operating system and hard drive and stuff like that. When you're doing saving, just to explain what the save load is, it's basically save game and load game. So when you're actually saving stuff on disk. I didn't expect any major performance boost, but it actually surprised me that we actually lost some performance in package build. And if I had to guess, it might be changing the location, or there is some more permissions that the operating system is asking for, or something is happening in the package build, so it's actually a little bit more expensive to save. Pretty interesting, but still I'm trying to save 6,000 save games and it cost me about 1 second. So if I go to my editor and let's go to our data save game, what we have in here is just random variables, and I just added random stuff in them just so there is something, and we basically create this and then we do a loop where we loop through saving them 6,000 times. I used for loop for also spawning and stuff like that, and there is a little bit of overhead for using for loop, but it was small enough that I didn't really care to try to take away, because it was probably like 1, 2 or 3% of the total cost, so I left it. Also in here there's probably a little bit just for 6,000 for loops, but it's just so small that it doesn't matter. For practical reasons, we are saving this save game 6,000 times. And I think in general this is pretty good, but just really surprising how package build is actually a little bit more expensive. Now let's go to load game, and I think for this one we can go to 10,000 because it is more performant to load than to save. So let's try load. We need load here. This is the load. Performance is a little bit better, so this is the last one I tested. We get a little bit more of a boost in the package build, but everything is pretty much the same, and it is a bit more performance. So we are doing 10,000 loads and we are doing it in 0.6, so we are about 2x faster than saving. So yeah, nothing much to say there, but yeah, hopefully this gave a little bit more insight in the optimizations that Unreal does to make your game more performant. And as you can see, I haven't tested too much stuff. I tested mainly for loops, recursion, and some spawning save load. Then there's a bunch of more stuff that can be added in here, so if you want you can add your own stuff. I was also thinking I could create a quick tutorial to make it easier for you to add your own stuff. So if you want that, you can leave a comment, and if there is people wanting the tutorials, I can just create one. It should be like 10 to 15 minutes to create, so I can just create one from scratch and kind of show you the whole process, but it's not too hard. And just to finish it up with the folder structure, so we have this JSON, we're saving all of this data, how much in editor development package needed at the time, and also I have this window, so when I package it for development, then just rename it here and then rename it for packaged, and also Git is ignoring these two files so I don't push every time this stuff. So yeah, pretty interesting stuff. I think save and load and spawn actor are pretty interesting, and hopefully this helped you get more insight in the optimizations in Unreal Blueprints.